All right, welcome back to Mr. P Helps with Calculus. This is Unit 2, Day 8, and this is going to be one of my favorite things to teach, which is finding derivatives of trig functions. And we're not just going to learn the rules, which is something you will have to do in this class, but we're also going to see why the derivatives happen to be what they are, which is something we're going to explore. Now, this warm-up here, and normally I kind of skip warm-ups, but I'm not skipping this one because this really wasn't focused in a video in the past, but I did mention it. This is one of those questions they love to ask on the AP exam, or this is kind of the stuff that they love to ask about, especially with the materials that they provide for us for studying, is instead of giving us a function, they're going to give us the limit definition of a derivative. They're going to give it to us in this format, and you need to be able to look at it and determine what am I looking at. So instead of finding the derivative, you're going to find it doing the easy method, which is just using the rules, the power rules, and the sum and difference rule, and the constant multiple rule, all those easy rules that you've now learned from the last video. And what we're going to do is we're going to look at this format knowing that this is f of x plus h minus f of x over h, which is the most commonly used format for limit definition of a derivative. You should know that this is really f of x, and all of this is the exact same thing, but instead of having an x, it has x plus h. So this is really x plus h squared, and minus 4 times x plus h plus 3. Happens to be everything exactly the opposite. Now, you might be wondering, why is everything exactly the opposite? And the reason why is because of this minus sign right here. Because basically what's happened here is it's already been distributed. It's already had this negative sign being distributed. So really, it's x squared minus 4x plus 3. And then if you subtract that, so as I'm looking at this, clearly my notes aren't right here. This should have been x squared because what I just said should have been right. So let's change this because this basically tells you this is really x squared. Let's move this to pen. All right, so this is really x squared, then minus 4 times x plus 3. Now, essentially what's happened here is this is then minus just that original function. And that's really why you have minus x squared. The opposite of negative 4x is positive 4x, and the opposite of positive 3 is negative 3. So essentially what's happened here is that instead of minus f of x, that negative sign has already been distributed to all of f of x. So f of x is really minus 4x and plus 3, which I believe is going to change a little bit. Okay, it's only going to change this. So it looks like 2x minus 4 is the derivative. All right, now getting to the actual video itself. Now we made that quick change. How do we find the derivative of sine of x? Well, you should be very familiar with this green function. This is sine of x. It has a range, it has a domain that goes infinitely in both directions. So this will keep going this way, this will keep going this way. It has a range of negative 1 to 1 because the lowest it could possibly get is negative 1. The highest it could possibly get is positive 1. And you learn that sine of x in Algebra 2 is really just the height. If you did that carousel activity, which I think most of us probably did. So this is, 1 up here. This is negative 1 down here. And essentially, sine ends up being y over r. Okay, so knowing all that. So it's really the height. All right, so this is y over r. You start with a height of 0, then after a quarter of a turn, you're at a height of 1. After that, you're at a height of 0 again. And then you're at a height of negative 1. And then you're at a height of 0 again when you get back to the start, which is at 2 pi. Because it takes 2 pi radians to make 1 full rotation. All right, so after that quick review there. So what does that mean? Well, let's find the slope at all these given points. If green is sine of x, the slope here is about 1. So we're graphing the derivative graph. The slope here is about 0. The slope here is about negative 1. The slope here is about, the slope here was 0. The slope here should have been positive 1. Positive 1, 0, negative 1, back to 0. And then the slope here is positive 1 here. Sorry, I got confused with which one I was looking at. Now, this is familiar. This is interesting. The green sine graph has this graph as its derivative graph, which is the cosine graph. So the derivative of sine is cosine. Now I know what you're thinking. What does that mean? The derivative of cosine is sine? Well, actually it isn't. And we're going to explore that in the next one. Here's what a cosine graph. That blue one is literally what we just had on the last video. So let's do the exact same thing. Slope of 0, slope of -1. That's a big difference there. Slope of 0, slope of +1, slope of 0. I almost did it again. All right, so now this is not a sine of x graph. This is the opposite. This is -1 times sine of x, meaning instead of going up, because sine of x is supposed to go up at the beginning, it's going down. Everything's been flipped over the x-axis. So the derivative of cosine of x is actually negative sine of x. Now, e to the x is another one. I think I've already explored this in a past video, that literally e of x is special because the derivative of e of x is itself. If you look at every single place here the slope is like not quite 1. It's less than 1. This is even less than that. And then this is when it gets to be a slope of 1. And then this gets a little bit higher. This gets a little bit higher. All of these slopes happen to be the exact value of f of e of x. So whatever that function is, whatever x is, the height at that place happens to also equal its slope. That's what makes this function quite special. It's the only one that does that. It's the derivative literally of itself. Natural log of x. Well, this doesn't quite work out so easy. The slope here is really, really highly negative. And then it gets less and less and less and less negative until it evens out and gets closer and closer and closer to a slope of 0. It doesn't quite ever hit a slope of 0. So really, natural log of x looks like the exact same thing. It basically looks like 1 over x. This is 1 over x. But there's a difference here. And the very important thing to forget, easy to forget about, very important thing to not forget about, that this is not, everything on this natural log of x is on the right side of the y-axis. Meaning the domain is everything greater than, this has a domain of everything greater than 0. Meaning none of that graph is on the left side of the y-axis. Now why is that important? Because the original function was just this. Now there's nothing on the left side, so this piece does not exist. We have to limit the domain on this. So basically we have to say that's 1 over absolute value of x, meaning only the positive side. This is not a part of it because it's only being, it's not really quite being flipped, but this derivative graph is only using this piece when doing this, because we're just talking about the slopes of that graph. Nothing on the other side. It can't be a negative. Negative side of x doesn't exist. All right, so what do we have next? Determine the derivative of each function. So it looks like we're just putting it to practice. Let's be honest, this is just using the same things. The derivative of natural log of x is 1 over x, right? So d dx of this is this. Use your simple power rule to find the derivative of that, and then just simplify. Derivative of cosine is negative sine. This is just simple power rule. 3 times 2 is -6. And then drop that by 1 makes it a 2. So that's all you got to do for that theta. And then over here, 3 times sine of x. Okay, remember, sum and difference rule. This splits it up into 2 different pieces. Derivative of e the x is itself. And over here, you can use your constant multiple rule and do 3 times d dx of sine of x. You could do that. And derivative of sine of x is cosine of x. And then just leave it. 3 times cosine x. All right, I think that's it. Thanks again for watching. I'll see you on the next video.